Alright, so here is our final project for 368. The code is all of this. We have multiple classes for the algorithms that we use, as well as some other helper classes. So we compile it. I run the make function, which runs our make file here, and this just contains the rules for how to make all of the files. So you can look at that more in the source code. But at this point, I'll just run the make command, and then it compiles all of the source code files separately, and then we'll link them together at the end. So after a little bit of time, we have our executable, and it's called main. So if we just run main, it says it expects some parameters to be in the program call. So it says run the program, then have some optional options, and then a action to do, and then the tickers to perform the action on. So for example, if we were to run main help, then you can see all of the help that it says. So this is the same sentence or statement it said before. Here is the explanation for all of the options. So let me clear this. Okay. And now I will do the simplest thing it can do. It can optimize Apple. Okay. So what this is going to do is run a lot of simulations for each algorithm that we have in here. As you can see, each algorithm is a little bit slow to optimize, but as you can see, as it's optimizing, it spits out the percentage is completed, the time elapsed, and the time remaining. So we can let this run for a little bit. But it's not really too exciting. It just optimizes all of them. And that's it. Okay. So what that created was these output files. So for example, for the RSI algorithm, we can look at RSI and the raw output for Apple. Okay, so this is the output of the program after all that. And it says it ran the simulation using these parameters, and it outputted these parameters, or these outputs. And so it continually runs the simulation for all of these parameters to get all these outputs. So then what we do is we use all of those output files to run a analysis of Apple. So that's a lot quicker, as you can see. And then it spits out a number that says Apple has a signal of 38 on today. And so what that means is there's a strong signal to sell Apple stock today. So a couple more things, some options that you can throw in there. So if you want to see what algorithms spit out what results, you can run it with the verbose option. So we run it for Apple, you can see it has the same number as here, but here you can see the number is composed of multiple algorithms, and each algorithm has a specific output. So it adds them together to compose this final number. Now you also might be curious what the option TBB is used for. So that's used when you're optimizing. So it's a little slow if you are not using TBB. But if you do TBB optimize Apple, it doesn't tell you the status, but as you can tell, it's a lot quicker than it was before. Right, so that's all optimized. It does the same actions as this, but it's a lot quicker. And the reason for that is it uses TBB to run multiple optimizations in parallel. So if we take a quick look at the processes on the computer, we just run it without the TBB option. If we look over here, you can see that a single core in my computer is operating, right? So we have all of these cores up here that aren't being used, but a single core that's being used 100%, okay? And then if we stop that optimization and we optimize it using TBB, then I'll run that, and then you can see it spreads the load out upon all of the cores. So the full computer is being utilized. And as you can see, it's a lot quicker than it was before. So that's our final project for CS 368. Hope you enjoyed it.